You're listening to Coding Blocks, Episode 7.
Subscribe to us and leave us a review on iTunes, Stitcher, and more using your favorite podcasting app.
Visit us at codingblocks.net, where you can find show notes, examples, discussion, and more. Send your feedback, question, and rants to comments at codingblocks.net, and be sure to follow us on Twitter at codingblocks.
And with that, welcome to Coding Blocks. I'm Joe Zach.
I'm Michael Outlaw.
And I'm Alan Underwood, and today's show is about solid.
Solid.
Wait, is that soiled?
So, yeah, I'm glad they went with solid instead of soiled.
Yes.
It would have been a lot more interesting, though.
Yeah. So, solid is an acronym. It's, 5 letters that were come up with by this guy, Michael Feathers, who, if you live under a rock and haven't heard of him, he's one of the object mentor guys. He's internet famous. He wrote Working Effectively with Legacy Code. He's kind of a big wig in the programming world. And he came up with this term solid as a acronym for kind of some rules to follow for creating good, well-designed software.
And object-oriented. Right?
Object-oriented.
Yeah.
And well-designed means that it works.
Yes. So, what exactly...
Wait, I was right?
So, I mean, what exactly was well-designed code mean, though, right?
To me, it means easy to change successfully.
And what about reading and maintainability and...
That's debatable.
Yeah.
That's not really debatable. It's got to be easy to read, right? But as we talk a little bit about this a little bit more, we're going to see that a lot of the principles that these 5 letters stand for end up with a lot of typing initially. But I'd like to argue that the initial writing of something isn't that important, because you're going to end up reading it and maintaining it, 100 times over what it takes to originally write the code.
Yeah, and before we get into this whole thing, because this is something that's repeated throughout, a lot of these solid principles, they actually state that you don't necessarily want to do these starting out, because when you get into these things, you'll find out that you end up writing a lot more code to do them. So the whole idea is there's this fool me once, shame on me, fool me twice, or fool me once, shame on you, fool me twice, shame on me. So the whole idea is, if you find a need, then start going in and refactoring your code to follow some of these principles. Now, some of these principles you want to try and adhere to as much as possible, but others really do take a lot of work to get into. So that's just kind of, prefacing what we're about to get into.
Well, yeah, I can't speaking from my own experience, though, a lot of times it's more, there's so many times where it's just exploratory what you're doing.
Yes.
So you don't always have a clear-cut class library in mind that you're going to write out.
Yeah. So that's just a forewarning. These are things that you should try and adhere to, but as we get to some of the principles, we'll mention those specifically as to, which ones you're probably not going to just start out writing that way.
Right. And I would also mention that, these are 5 principles for writing well-designed code, but there are other principles too, like Alan talked about YAGNI, you ain't going to need it. And there's also this rule of 3 that Jeff Atwood recently mentioned in a blog post. But basically, the more reusable and well-designed something is, the longer it takes to write and initially maintain.
Yeah, and, there's also dry. Don't repeat yourself.
Right.
There's a lot of principles out there. But this is a pretty good one. This is fairly encompassing, so that's why we chose to go with this.
Because it's solid.
It's solid.
And speaking of dry specifically... the first principle, the S stands for the single responsibility principle. And this actually is one I struggle with a lot, specifically when it comes to dry, because if I've got these classes that only have a single responsibility, only one reason to change, and I have a lot of classes, then a lot of times some of these classes end up kind of looking similar to other classes. And it's because these classes don't know about each other, not using the same code. And so I kind of end up falling into certain types of patterns with them, which is, maybe a good thing, maybe not.
Yeah. So depending on which route you go, you will be in conflict with one of the other types of principles out there. But, again, generally speaking, we think these are pretty good. So getting into the single responsibility principle, as he mentioned, that's just, it should do one thing and do it well. and that's it, right? It really follows the rule of encapsulation, right? Everything should happen within that class that needs to happen in that class, and each method should only do one thing, and it should be fairly short and concise.
Well, I'm just still trying to follow along with Joe's comment, though, that he made regarding S and adhering to dry, though.
Yep. So what I kind of mean there is that, if I'm doing some sort of like, let's say a tic-tac-toe program and I'm trying to do it in a solid way, and I'm by no means an expert and end up kind of creating a ton of classes, a lot of times some of the classes will have a lot of, not necessarily boilerplate, but a lot of the same kind of patterns. So what I mean for that is if I'm trying to truly be dry in a tic-tac-toe game, then I might have a class that says whether a particular game is a horizontal win. I might have a class that says it's a vertical win. I might have one that's diagonal. This is probably way overkill, but it's kind of an example of something you could see where you've got three classes that have very similar functionality that if you really do those in three separate classes, then you're going to be duplicating some code.
Yeah.
Maybe some inheritance there. I don't know. Maybe that's a difficult example to follow.
But that actually follows another pattern we'll get into in a little while. But
yeah, and one thing, the thing, like I mentioned, I struggle with the single responsibility principle all the time, and I think that if you really try to work on it, if you really try to adhere to this principle, then you are going to experience some serious pain. But as a programmer, I think you got to kind of like this kind of pain anyway. So it's not so bad.
Are we all masochists now?
Yeah, I don't know that you can ever have any piece of code that adheres to every rule out there that somebody's going to be able to put a rubber stamp on and go, yep, this is awesome, it's solid, it's dry, it's whatever.
But we can try. We may never finish what we're trying with, but we could try.
Actually, if you did that, the application would probably do absolutely nothing. That's my guess.
Yeah, it would be too abstract.
Yeah.
Would that be maybe just a class with an empty implementation?
An interface. One interface with nothing in it.
We've solved the problem of all applications now.
Perfect software.
So an interface that defines some method do stuff.
That's right.
So what's one of the downsides of this? I think Joe already touched on a little bit, and that's just a ton of classes, right?
Absolutely. Every time I try to go down this path, I end up with classes upon classes upon classes. And they're all really small and easy to understand in isolation, but the big picture gets messy, and I'm probably just doing it wrong. But every time I try, I mean, maybe we're talking like multiples.
Maybe some aspects would help you out there.
Yes, that's why I need more frameworks.
But so you get a ton more classes.
Wait till we get to dependency inversion.
Yeah, it's coming up, guys.
You get a ton more classes. You get a lot more arguments, and honestly, it becomes a little bit more challenging to follow because you do have so many classes and so many files and whatnot, right? I mean,
but it makes the unit tests a whole lot easier.
Unit tests are a huge reason why you want to do this. Yeah,
absolutely.
So you can actually test your code easily.
Yep. One thing I think that's really funny about the single responsibility is it kind of flies in the face of all sorts of easy stuff. Things where you might cheat, like throwing something in session memory and accessing it, like a few pages later in a web application, or maybe using like a singleton or something. All sorts of easy patterns, just throwing a query in the page or in the application. These things are like strictly forbidden if you're trying to adhere to the single responsibility principle.
Yeah,
I don't know why you got to throw my singleton pattern in there. I love that guy.
I do too. And with Sharper, it always gives you the little squigglies to let you know when you can make something like a static class or a static method. And it's great because it's efficient. But, a lot of times you're creating these singletons, which are bad because they control their own creation and life cycle, and they often hide dependencies. And every class that calls them is directly coupled to that concrete class, not an interface. So it's cheating.
I could show you some examples where it's not, where it can still be interface driven.
Yeah, but a lot of times, if you've got a singleton, like I always tend to think of static classes as singletons, but it's really not the same thing. But if you've got a singleton that does stuff like, has a method like get user ID or something like that, then a lot of times that's we're actually talking to a database or to a file system or to something that you're directly coupling now to your classes and to your entire application.
Yeah, I guess I was just thinking like we're way off the topic of single responsibility, but I was just thinking of the Singleton, because I got to defend my guy here.
Yeah.
got to defend my boy. The Singleton could implement an interface though, and you could still have some way of abstracting that away so that you're not directly aware of the concrete class.
That's true. And actually, as far as dependency injection goes, it's pretty easy to configure something as a Singleton. And so your calling classes don't even know that you've only got one instance of it. That's just kind of a more difficult way of setting that up.
Yeah.
All right, so moving on to the next one, we have the open-close principle, which is the O in solid. So this one is pretty straightforward. It's saying that the class itself should be closed for changes, but open for extending. And I mean, that's pretty good design practices. You don't want to go in and start changing the underlying pieces in a class, because anything that's been using that class will potentially break at that point. I mean, you can go to great measures to make sure this backwards compatible and all that kind of stuff, but anytime you start touching code that's been out there for a while that other people are using, you run the risk of breaking things.
Well, if I could put that into different words, though, the idea here is that if you want to extend a class, so you have some base class, and you want to make a subclass of that, then you shouldn't need to modify that parent class in order to make that child class work.
Yeah, but I can think of some examples where that's been really helpful. For example, equals. String equals string. The actual equals method that belongs to the actual object can be overridden, and it's really convenient for something like a string where these two things have different references, their reference types, but the actual string compares, the characters of the string match up with the characters of the other string, and so they kind of override that method in order to provide that.
But that's not what this is talking about, though. Like overriding a method.
No, that is part of the open close thing. Yeah, no. So that's.
No, I thought it was like if you had to actually modify the code of the parent class.
You shouldn't.
You're not modifying the code of the parent class here. In a subclass, you are overriding a method.
Right,
to give it a new meaning.
Right, and that's good. You're actually overriding slightly different. They talk about extending, which would be overloading as opposed to overriding, right? Like if you, so what they typically speak about is instead of having an equals, you might have another equals that takes in a different type of parameter, something along those lines, so that you overload the method. So you're not changing the original meaning of the class, but you can extend the meaning of that class.
Right, and it's kind of a weird thing to think about, and I love the equals thing for strings in particular, but if you have an array of objects and you compare it to an array of other objects, and some of those objects are strings, then they're going to behave differently. They're not just going to be looking to see, am I really the same instance? They're going to be comparing the actual, the value of the characters. So it's kind of a weird situation, but it's helpful, and I imagine it's a calculated risk, and Microsoft decided that it was worth it.
Yeah.
Well, yeah, I stand by my understanding of it, which was that it's saying that you shouldn't have to modify the base class.
Yes, that's true.
Yeah,
yeah.
Overriding a method is okay, right?
It's slightly different. You're not really extending it at that point. You're just kind of changing what is. I don't know. Maybe we have a slightly. Yeah, you're not changing the base class, so that's good. To what you just said, that's good. You basically, if you create an abstract class or a base class or something like that, you shouldn't be changing it. Pretty much, you should be able to extend it.
So okay, now if I can quote from Wikipedia, the open close principle is such that an entity can allow its behavior to be modified without altering its source code.
Yeah, the code, right.
And so in the override example, you are not changing the source for, say, object, right? But you are modifying, some other some subclasses behavior by overriding methods and functionality, right? So that's okay.
But you should be able to treat a subclass. This is kind of getting into the next one, the Liskov substitution principle. But you should be able to treat a subclass like indistinguishable from its parent.
Well, okay, and so in your equal example, right? Like you don't want to know or care what the specific types are, but you expect that if you call equal, that you're going to get a Boolean result, right?
Right.
Yep.
So you don't have to care like which specific one is it. I just know that I can call this method and I'm going to get back a result.
Of a Boolean,
the expected result.
Right? Regardless of how it got that. So getting into this, getting further into this, there's a couple of things that are important in this, and one is using interfaces, which will come up quite a bit in this, and using things like template methods. And really all we're saying is it's important if you have abstract classes or if you're using interfaces, the way that you make this happen with the open-close principle is you can just override the abstract classes methods, which is what Michael Outlaw just said, or you start implementing the interface methods. So pretty much when you go that route, you now further extend those classes without changing the source of the base class, which is huge. The next is the strategy pattern. And this one took me a minute to wrap my head around because it's so close to some of the other ones. But essentially what you're doing is instead of using just polymorphism, which requires classes to implement the same method repeatedly, you're basically creating classes that have let's do the example that they actually had on Wikipedia, and we'll include the link in the show notes. They said, so you have a car class, and in this car class or interface for this car class, you have a braking, a braking method. And the thing is, that's all fine and dandy when you've just got 3 cars, because you've only got 3 implementations of braking. Now, when you start getting into hundreds of cars, these are all implementing this braking method, and they all basically are doing the same thing.
Well, I want to be clear here, because you said that you have to implement this method over and over and over. So you're talking about an abstract where you're expecting that that's going to be.
Well, let's say you have an interface that says it requires a braking method, and now every single car that implements from this car class using this interface now has to implement that braking method. And the whole problem here is when you have 100 cars, most of them all brake the same. And so you were basically repeating code over and over and over again, potentially up to 100 times. So the solution in this strategy pattern is instead of having these methods all self-implemented on each one of the car types, is you have various braking classes that override from the interface. So you might have braking with standard brakes, braking with ABS brakes, braking with drum brakes, braking with disc brakes. And then that way, now you only have 4 classes that each one of these car classes have a reference to for their braking type. And now you haven't duplicated the braking code over and over. You have these different ones that are using all come from that interface. And so now when you call the brake method, they know exactly how to do it properly without duplicating the code. So that's a strategy pattern. And that allows you to keep that open close thing, because now if you want to implement a new type of braking, they come out with something great in the future for, I don't know, air driven brakes or something, for cars, then you just add a new class. There we go, carbon brakes, right? So now you add a new brake with carbon brakes, and you didn't have to change anything else in the class. That's available to all the other classes that need to be able to brake with that type. So you're not having to go, and you don't have to peek into every single car type now to see what the braking methods are. You can actually see, this one's braking with carbon brakes. I've just got to go look at that. Your Jaguar is braking one way and your Ford's braking another way. All you have to do is look and see at the type of class that it implemented, and then you're good.
Okay. So, those are ways to maybe help adhere to it.
Yeah. No, it's a pattern that you use to adhere to the open close. So the whole point is now you don't have to go back into that base class and change any braking methods. It's all self-contained classes that inherit or that implement that whatever the iCar what the braking method is. Did that make sense?
Yeah, except but again, at its purest though, like what this one is saying though is that if you have that class car and you want to make a subclass from it, then you shouldn't have to modify car.
And that's exactly what this does. You're not even having to modify the braking method. That car class is going to have a reference to a braking class that implements an interface that defines the braking method. Now that way, you're never touching that class again. That car class now has a reference.
I think I follow what you're saying in your example, is that in that child class, you would then set that, like that would be some variable.
Yes.
Braking.
Yes.
Or brakes. And you would set that to, new carbon brakes.
Yes.
All right. I follow where you're going with that now.
So now, and the thing that does is it allows you to not repeat your code everywhere, because now you don't have 100 different cars that all have the same carbon brakes on them, all defining their braking exactly the same. You're not copying that code everywhere. You now have one class that defines that for you. So, that is the strategy pattern. There's another one that Joe likes a lot that is the template pattern. And, you want to give that one?
Yeah, sure. So, somehow this is just one of those patterns that I picked up along the way and find myself keep on implementing. But what I'll do is I'll have like a collection of like rules or commands, and I'll loop through until I find one that meets some sort of criteria, and then I'll execute that action or command and then kind of buck out of there. And I'm not totally sure I'm doing it right, but this is just something that I found helpful over and over and over again. And what it allows me to do is basically add and take away rules, these little independent kind of chunks, and I can focus just on those little areas. So if you've got a sales engine or something, I might have a little rule that says if this item's on sale, then reduce price by X%. And I might have another rule that says if this item is eligible for buy one, get one free, then, return 0 for the price or something like that. So I've got these little kind of very small classes that each do one little thing that I can work on in isolation, and just seems to work out really well for me, and I abuse it.
Now, the interesting part is we talked about earlier is you typically don't write this stuff this way starting off. This is what he just said about the sales thing is a perfect example. When you first do it, let's say that you're writing your own cart, you basically have an item price, and that comes in, and you say, hey, if the item price, if it has a sales price, then use the sales price, otherwise use the regular price. That might have been how you wrote the thing starting off. Then all of a sudden your boss comes to you and says, hey, we need to do a buy one, get one. So now you've gone in there, you've got if sales price, or if buy one, get one's on the item, then use that. Else, if sales price is on there, then use that. Otherwise, use price. Now you've had to go back in and modify it. At this point, you can probably look at that and say, oh man, they might be trying to do buy two, get one next go around. So at this point is probably when you'd want to come in and think about refactoring this code to give like a pricing engine, like what Joe just said, where you have rules and it runs through and executes those rules. So then the next time that comes in, all you have to do is add a new rule, and it will automatically loop through those rules, find out which one applies, and then run it. So
this also...
sorry. Well, I was going to say, like, where I've used this a few times has been in a situation where in a base class, there's a method that is expected to be ran, and it'll have a bunch of hooks in it that it calls out to virtual methods that then child classes can override and provide their own implementation if they want. But the point is that when you use that base method to run that method, then it'll call out to the hooks that may or may not have been implemented and still provide for a consistent experience.
Yeah, you won't get any runtime errors because that virtual method is basically saying, hey, if it's not there, it's just going to be a void call anyways. So,
or an empty method call,
or an empty, yeah. So yeah, all these things that we just said are basically saying, if you know that there's things that are going to be called in external places, or you're going to need to check multiple things, you can basically set these up in a way to where there are classes that implement an interface that the base class knows how to call, and then you're pretty much safe at that point. And it's very extensible. You just need to add a new class in the future, add it to whatever list or collection you might be using, and you've just now extended it without ever touching the base class.
Right, and this also ties back into the single responsibility principle where, and the example of kind of having if it's a sale item or if it's buy one, get one free, those are all examples of multiple reasons why a class would change. So if you've got one class that knows all these different rules, then this is a class that you're probably going to be modifying all the time.
Yeah, if you see a bunch of if-elses, then that's probably a good indication that it's a place where you could start abstracting this information away.
Yep, and I like that. That also kind of ties into like what Michael and Al were saying, and I was totally wrong about, which is basically the close for modification. The source code is inviolate, and what that means in part is that the classes that touch your class shouldn't have to be retested. So you shouldn't be changing these small little classes that often. And when you do change them, it should be something that still kind of lines up with your expectations of how it worked in the beginning. So these classes that end up, a couple years later being used all over the place, it's kind of scary to change. So what you want to do is have these little tiny things that are safe to change and still adhere to their interface, and just kind of keep on working.
Yep. All right, so
this was the one with the "Don't call us, we'll call you."
Yeah, so the
motto.
Yeah, they call it the Hollywood principle, and it didn't make sense to me as far as why they call it the Hollywood principle. But the example that Outlaw gave is what it means. So he has a base class that's making a call to methods from classes that implement an interface. So this base class assumes that this method exists in whatever base classes are being defined. So what he was talking about with the virtual methods,
interface, like it could be like in the child classes.
It could be the virtual, like what he just mentioned as well. But basically, that base class is going to be calling a method, and it expects it to be there, and it expects it to be implemented in a way that's not going to throw an exception. So from that perspective, that's saying the base class is going to call the methods and the things, not the other way around. So your code shouldn't be calling it. The class that implemented those should. So it's pretty interesting. Yeah,
and so we've talked about the single responsibility principle, that's the S, and the open close principle, the O. The next one up is the Liskov substitution principle. And I actually got a little bit ahead of us talking about the modifications. But this is the one that I'll give you the definition first. It's basically objects in a program should be replaceable with instances of their subtype without altering the correctness of that program. And this is where you, if you've ever heard of the famous example of the square and the rectangle, where a square is a type of a rectangle, but it's got these additional restrictions where the width and the height have to be the same. And so this is basically kind of a violation of this Liskov substitution principle, because there are things you can do to a rectangle that you can't do to a square, like squish it, whatever. So if you had a method that maybe took a rectangle or a shape object and stretched the width, then that would be something that should break the square class. And now you've got an example of something where you can do something to a parent but not a child, which is kind of a backwards way of thinking about that relationship.
Yeah.
You guys never heard of the square rectangle?
No, I guess what I was thinking of is and I was just trying to figure out like how to put it into words. If one, I'm trying to think like which one would be the parent, the square or the rectangle. But if you had a class where you were setting the property for it and you just assumed, well, width and height are going to be the same.
Mm-hmm.
Right?
And that's part of the square rectangle thing that breaks it, yeah.
But I was also thinking, too, though, that this substitution principle fits in nicely with the base class example that I was talking about before, where the child class can run the same as the base class.
Right.
And the base class can run without, it might not do as much, but either one was substitutable for the other
Right.
in terms of execution, which brings me into this little note that I had here, which is, when in school you're taught from a object-oriented perspective, the is a relationship for classes. And so I wrote here when we were putting our show notes that ISA has been deprecated and replaced with is substitutable for.
Yep.
Okay, nice. Yeah, now what I kind of like about this is if you reverse this Liskov a little bit and kind of think about it in a different way, it also kind of implies that you can take in a higher level of abstraction. So if you've got a class that, takes in a car and prints out the two-string of it, then maybe you could just take a string instead and do something with basically the highest level of abstraction that you can deal with. That wasn't a great example, but for me, like the way I actually think about it a little bit more tangibly is I go around and if I've got a HTTP request class and a IHTTP request class, then I can go ahead and swap that request argument out, the HTTP request argument out with the IHTTP request interface. So I should only be dealing with those methods through the interface. And I can do that sort of thing because I can trust, or I should be able to trust, that those behave in the same way.
Yeah, well, there's a note here as well that if you have to inquire as to the type of whatever objects...
But you got to say this like this was a perfect Jeff Foxworthy moment. If Jeff Foxworthy were a software developer, if you have to inquire as to the type of your object, your code smells.
Nice.
So what that really means, though, is if you're having to look at all the objects passed in and say, is this type box or is this type square, then do this. If this is type rectangle, then do this. If this is type circle, then do this. Then the problem with that is it might seem perfectly fine when you only have 3 or 4 objects, but as more come in, now you have a triangle, now you have an octagon, now you have a pentagon. All of a sudden, you're having to go back in and change those base classes, which...
I can think of an example where this is done quite often.
Oh, really?
Can you guys? You guys got any?
Type of JavaScript.
String format? Nah.
The example that I was thinking of, go back to your web form days, is in a repeater, and you're doing the if it's a list, alternating item or list item. Yeah, you're inspecting what the type is and deciding whether or not you want to act on it or not.
Right. Yeah.
Or how you want to act on it or not, because there's a lot of event driven type objects where you're getting the lowest common denominator back
object,
into it, and then from there you're trying to inspect. You have to inspect it to say like, okay, well, what actions do I need to take from here? Yeah,
and so just as a heads up for the way to avoid that, instead of having is type of square, is type of rectangle, is type of circle, instead, let's say that you're trying to run the area of them. Each one of those objects themselves would have a method called getArea, and then you would be able to take in an eye shape, a type of eye shape, and you would say, getArea. So then, now instead of you having to inspect each object to find out what it is and then call get rectangle area, get square area, get whatever, they all have the same method on it. You just say getArea. And so that's how you get around that is type of, whatever.
Well, there was another note that I had here too, and that's that if your subclass requires something that the base doesn't, then there's a good chance your code smells.
Yeah. I listened to the Perl site course on the solid, and what he said is you have a base class, a duck, and then a subclass that is also a duck, but it requires batteries. Chances are you've violated this principle.
Yeah, I'm trying to remember what his name was.
Steve Smith. And the reason I remember that is because there's an NBA player by the name of Steve Smith back in the day. So, whatever works.
We'll make sure to put that in the show notes.
Yes.
And I would also say that, or would you say that casting is kind of a smell that you're violating the Liskov substitution principle?
Probably, because you should be returning the interfaces, right? And then you don't have to cast the things. Or
yeah, you should be able to deal with it at that level of abstraction, or else you should probably take the more specific type.
So are we going back to a previous episode where you always wanted to convert your IEnumerable to list and your to list to IEnumerable?
Yep, over and over and over again.
And if you don't know enough about interfaces right now, now's a good point to pause this particular episode and go back to, I think it was episode 1, right?
Yep.
I is for interface.
Yeah, I is for interface.
www.codingblocks.net/episode 1.
Yeah, so we talked about interfaces ad nauseum there. But again, those are an extremely important part of this entire solid set of principles.
But Joe brought up an excellent point. I've never really thought about it, though. Like, is the casting a violation of that?
It certainly feels like it would be.
Yeah, you're saying like I'm taking in an object, but really what I need to do is something to this specific type. So yeah, it's definitely.
But you're not interrogating it necessarily to say like, well, what type are you? You're just saying like, I want you to work as this type.
But that means you're making assumptions, right?
Oh yeah, I'm not saying it's good.
So, but in the perfect world, let's say you're not working with third-party APIs or anything, you would be able to just know that this is of a particular implementation. You know, it's a shape. So this shape, I should be able to call get area. I shouldn't have to say, okay, cast this as a circle and get that type of area, you know?
And if I've got a rectangle, I should be able to say set width to 2 and set length to 4. But if I've got a square that's also a rectangle, then, you know, do I throw an exception? What do I do?
Well, no, at that point, you just, whatever the last one was, you set both of them to 4, right? So
that works for me. That's an example of one of those headaches that, we programmers love.
yeah, so I don't know. The casting thing's kind of up in the air, but
Yeah, I'm going to be thinking about that one all night. I had never considered that.
so, all right. So now we're going to move into number 4, which is interface segregation principle. This is probably Joe's baby.
These are the people that provide my internet connection, right? My ISP.
ISP. That's it right there.
Yeah, so-
and which have been throttling our Netflix, by the way. So yes, yeah. If we want to go down that road, we can, but I'm guessing we don't.
So this is my favorite of the solid principles, and that's because it results in more interfaces, more smaller interfaces, even more specific. And that's because it basically, if you've got a method that does something to an interface, then it should only really know about the things that it needs to do or needs to touch. So we kind of talked about the car example. If I've got a class that does some braking and it takes in a car class and it'll tell the car to brake and give it whatever information it needs to do, then it doesn't really need to know about the whole car, right? What it really needs to know is about maybe what kind of brakes it has and when the last time the brakes were serviced maybe, and some other type of stuff. And so what you kind of ought to have, according to this principle, is an interface that only specifies the information that is needed for that particular method, and then your car class can actually implement that interface. So rather than just taking an iCar, it might take like a iCar brake information interface.
Yeah. And the really key part about this is it allows you to use interfaces without having to implement a bunch of things that don't matter to what you need them for. One of the examples that Steve Smith gave in his Pluralsight course was the old membership provider in .NET. Apparently, it has like 60 things that you have to implement. And the problem is, if you're just trying to do a login form, you really only need 2 things: username, password, and maybe a couple others. But in order to use that now, you have to implement 60 methods or however many there are. And you have now broken the whole purpose of why you would use an interface in the first place.
So if I put my Jeff Foxworthy hat back on here, I wrote, if your interface requires a lot of methods to be implemented that often aren't needed, your code smells.
I like it.
Very nice.
Hey, if you implement an interface and use throw new not implemented exceptions, your code smells.
Agreed.
Yes. And another reason why we talked about interfaces being so important, and you ran on it earlier, unit testing. If you have little tiny interfaces that only have small things or whatever's just required for that to work, your unit tests are now very easy to write. because you can throw in your own, mocked up classes to do what you need to do. So that is a huge benefit of that.
Yeah, agreed.
So small is the way to go.
Yeah.
Small and mini.
Small is the new big.
Now, the interesting thing, going back to our interfaces thing, we talked about in our first episode that one of your things that you didn't like about interfaces is they get all spread throughout the file system. One thing that Steve Smith did mention in his Pluralsight course is he puts all his interfaces in another folder. So, or he might put them in subfolders off his solution in various different places. So that's one thing that you could do, because technically speaking, the interfaces don't really,
So I like that, but the problem is then you have to decide whether you want your namespace to be different so that it matches that of the folder, or if you want to violate basically the tacit rule that your namespace matches up with your folder structure.
Right. So, it can be done. It doesn't hurt anything, but just something to think about.
Yeah, I keep them close, personally.
Yeah.
Close to my heart.
Sometimes I even put them in the same file. I know, it's dirty.
It's not terrible.
But when you've got a bunch of little tiny classes and your classes are singly responsible and they're, a bunch of 10-line classes, then suddenly it's not so bad to have two classes and an interface in one file.
Well, the only time that becomes dirty is if it's truly an interface that's going to be implemented by a bunch of other things, then it can get confusing as to where you're trying to find it, right?
Totally.
Yeah, I don't like that.
Yeah, it's kind of weird to have two in this file and then one somewhere else,
If they are classes that I expect to be publicly available, then I like to keep them separate. But there have been times where if it's like a private internal class that I'm only wanting to use within some other class, and then I'll leave it in there because I'm kind of, I guess in my mind, whether or not the reader interprets it the same way, I'm trying to signify, like, I really only anticipate this to be used here.
Yep.
So,
although I will say, if you're following these solid principles, you're probably going to end up with so many freaking classes that you can't really use the File Explorer much anyway.
Yeah, that's a good point.
You're going to have to be doing some Googling on your hard drive.
You can do that through Studio.
Yes, you can.
Yeah, Google through Visual Studio.
All right, so I think we've pretty much exhausted interfaces.
Are we ready for some dip?
Let's go to the dip. Dip, baby, dip. That's going back a few years, right?
Showing our age.
Yeah, a little bit.
Or Alan's age.
Yeah, whatever. All right, so this is the dependency inversion principle. And this is probably one that is probably the most, confusing, depending on which approach you take, because there's so much involved. So
it seems like this is the least solid description that's going to be given. Like,
yeah.
This is like the other ones are more simple. This one gets a little bit more complex, in my opinion.
Well, the way I think, if you follow through with the SOLI, the SOLI, then you're going to need some help managing this stuff, because it gets big and it gets crazy. And so the actual kind of wiki definition here is that one should depend upon abstractions, not upon concretions. Another way of saying that would be that not only do you take in interfaces for your methods and your properties, but also anywhere where you create these classes that are actually the concrete manifestations of these interfaces should really be coming from somewhere that's outside the class that's using it. So, the new keyword suddenly becomes a smell. Yeah,
it's really frustrating too. So there's a few ways to approach this, and I guess I should get a little bit closer. That sounds weird. So you can either pass in your dependencies via constructors, or you can do it through setters. And there's actually another method that's not as frequently used, and I can't remember what it is off the top of my head. But so the thing is, if you have a constructor, you just pass in your, whatever objects are or dependencies that have been created, you pass them in the constructor of another class, and then that class now knows exactly what it needs to use. The upside to this is that your class has all its dependencies as soon as it's newed up. It's ready to roll, and you know exactly what that class needs to have.
You just don't know what newed it up.
You don't know what newed it up. Yes, and we'll get into that in a minute, too.
Yeah. we talked a little bit about, kind of a car example, and this would be a little bit of an example of kind of a builder, but someone's got to create that car and put that together with the brakes and the kind of the brakes, and whoever's putting that together,
Ferrari,
definition has to know about those concrete classes. They have to say, create new car, create new disc brakes, create new this kind of tire. And that's a class that I just described there basically violates every single one of these principles.
Yeah.
So that's where the dependency inversion comes in.
Yeah, and if we're going to say that I can't use the new keyword, then in my my link expressions, I can't do anonymous types, which are sometimes fun.
Yeah, definitely. But solid is fun too. if you don't have to get anything done, right? Just kidding, I kid.
So now the downside to the constructor stuff is, first is you can't swap out any of those dependencies at runtime. So if you have some sort of notification class that if something happens, then it should be using a logger, otherwise it should be using email, then there's no way to swap that out. You basically have to pass in both an email notifier and a log writer notifier or something like that. So
or different types.
Potentially. But that's what I'm saying. Yeah,
Single responsibility.
So there's an issue with the constructor, and then the other going the setter route, you're basically, after you new up a class, which we'll get into in a little bit, after you new up that class, then you set the dependencies using property setters. Now the upside to that is you can swap out dependencies. Yeah, depending on whatever's going on in the class, you could say, okay, no, we want the notifier to be a logger, a file logger. Otherwise, we want it to be an email logger. So that's cool. The downside is when you new up that class now, the dependencies aren't there. So if things start happening and they're not there, then you could potentially get exceptions.
And see, here's another example where I don't get to use one of my favorite operators, question.
Ooh,
oh, that's a good one.
Yes, I like question.
Yeah, return it. But if it's null, let me set it first and with a new, and then return it.
Yeah.
Question.
Well, so let's also there's two other things we need to get into here. One is this is not all gravy. Like when you do dependency inversion, the downside is you can have huge object graphs. So if you are passing in all your dependencies, they have to be there at the time that the other class is being used, which means that if that class was never going to use that notifier, you still had to have that thing ready. It was already initiated and created, and it's being passed in as a dependency. In standard programming practices, which probably most people use other than going through solid, you knew that thing up when you needed it, right? So now you've got this potentially large set of objects being passed in that are dependencies that could be eating up memory and never even be used, depending on what's going on in your code. So that's one real downside. You kind of have to weigh whether or not the upside's worth it.
Well, I'll say another downside is that you're literally adding a layer of complexity. So if your idea is to make something that's more resilient and more maintainable, then you're going to be adding some extra code. So this isn't something you're going to want to do if you're writing Fizzbuzz. But, if you've got a large application, and it's something you want to consider. And I'd also mention that you don't necessarily have to go off the deep end and replace every single new, in your code. But it's something to kind of keep in mind, just like all these other principles, and something to keep in mind when you're designing and creating your classes.
Just in case if anybody got lost there, Fizzbuzz is a common interview question.
Oh, yeah.
But I'll also say, too, though, we've already just in the course of this conversation, we've mentioned a couple examples of places where Microsoft maybe you could argue didn't adhere to some of these rules. So I just using that as an example, like it's difficult to adhere to all of them all of the time.
Yes. And that's why they say when it comes up, more than once, then it's time to start thinking about how to refactor your code. Although dependency inversion,
I think Windows has come up a couple times.
Yeah. Time to rewrite it all. But dependency inversion is one of those things you actually want to do probably from the get-go.
Yeah, a lot of these things are really better for or easier to do in greenfield type applications.
Yeah, the part that I get hung up on with dependency inversion, and there may not be a great answer to it. Joe and I spoke about this for a little while. if you're not using something like Ninject in .NET or Spring in Java or, any number of other frameworks that create your own IOC containers, this is going to be nearly impossible, because where are you going to new up your classes?
You're going to be doing a lot of plumbing.
Yeah, and you pretty much have to use a framework. If you want to go this route, you're going to be looking at using a framework, because it's mostly done through configuration files or settings or whatever. And that's how your classes get instantiated. So,
well, correct me if I'm wrong though, but wouldn't, like, in the .NET world, at least, one of them earliest forms of this be in the config files where the culture and version and all that are specified for DLLs that you want to include,
probably
binaries that you want to include. I mean, that might not have been. Maybe it was their intention initially, maybe not, or maybe it was just a cool side effect. But that was an early example.
And also, because you're not doing any sort of newing up, if you're doing strict dependency inversion, it makes testing really easy. So rather than you actually, having a class that sends a physical email, it would take in all the dependencies to send an email, physical email. Then it makes it much easier to test, and you don't have to worry about who you're going to send that test email to every time you hit RT.
What does a physical email look like?
Yeah, I keep saying that, physical email.
Okay.
So
I'm going to have to go check my physical email.
All right, so taking this one step further, and then I think we'll pretty much be done on the dip, is in the Pluralsight videos from Steve Smith also, he takes it away from the code. So typically when we talk about dependency inversion, we're talking about our code. He takes it a step further and says, well, you can do this at your solution level. And so if you think about a standard application, you have your view, your client interface, your UI. And then underneath that, you have some sort of, in some cases, called a controller. But that's where, some of your logic takes place. And then you have your model, which is typically your database interaction. Well, the whole point of that MVC type thing is to separate those. Well, in reality, though, they're typically tightly coupled to each other. Your view is highly dependent on the controller, which is highly dependent on the model, which means you can't really swap out that model. You're going to break a lot of things. And so he actually goes into the whole way of where you can abstract those things away, and so you invert the dependencies there, so that if you needed to go from SQL Server to Oracle, then you could do that. Or if you wanted to go to a NoSQL solution, you could do that without having those tightly coupled things. So
was he suggesting that you just make them like NuGet packages?
No, I don't believe it was that. It was just adding other layers of abstraction in between them.
Just different projects?
I didn't get completely through the thing, but
sorry.
Yeah, so thanks for calling me out. But
ding, ding.
It basically boiled down to adding more abstractions. And one of the ways that he brought it up was back in the olden days, he was trying to show that you could swap out databases or whatever. And the problem is he might have his SQL Server project there, and then he would have his Oracle project, something along those lines. And then if he wanted to switch from one to the other, he basically had to go in and rename all his dependencies that were going from, calling his SQL Server project now to call his Oracle project whatever. Even if the methods were all the same, he was having to do this global replace. And so the whole goal was, okay, I shouldn't have to do all that stuff. I should be able to change this abstraction layer to say, okay, now this points to Oracle, or now this points to SQL through some sort of configuration. So that's really what it boiled down to, is creating that abstraction so that instead of him having to go through and do a global replace on all his namespace stuff, he could, more easily swap out pieces. And so that's interesting. But again, going back to what Joe said earlier, that whole 3 times thing, you start going this route, you're going to spend a lot more time architecting and implementing these type of, cross-cutting concerns and things in your application.
And that's really hard to do with brownfield applications, and also, as Michael said, exploratory type coding. And pretty much a good percentage of what I do is either exploratory or maintenance on brownfield applications. So I don't get a whole lot of time to really try to do things the quote-unquote right way.
Yeah, it can be difficult, and it's really challenging, especially when you're under deadlines. I mean, you're always balancing the extensibility and how easy it'll be to do over time versus, what's the trade-off? What's the benefit? Is it ever going to be touched again? If not, then it's probably not worth doing. If it is, and there's going to be things, then it's something you should probably visit and try and take care of. So,
yeah. So that pretty much wraps it up for the solid. Some additional resources we liked were we talked a lot about patterns in this episode. So there's a fantastic book, Design Patterns, the famous Gang of Four book. We'll have that in the show notes. Also a book called Clean Code. There's a guy I really like. I'm not sure how to say his name, but we'll have links to his blog here. But he wrote a really great article and has a little talk on moving from stupid to solid. And he's got an acronym there, STUPID, that stands for kind of common anti-patterns. And how to move those to like a more solid approach. And he's also got something really cool here where he's got, he calls them object calisthenics, which are basically a set of 9 rules for you to kind of try and build an application. And I'll just give you a couple examples here. Like one of the rules is not having more than one level of indentation. And I forget what the...
Don't use the else.
No else, no getter setters, stuff like that. So it's kind of stuff that's hard to do in your day job. But if you're doing little,
in your night job,
if you're doing a little tic-tac-toe app, then it's something that's kind of fun. And actually, we'd love to see, some examples of what you guys are doing in the solid way. So I was actually planning on doing a little tic-tac-toe example that was as solid as a rock. And we'd love to see what you guys could do too.
Yep.
Along the resources, Alan's mentioned a Pluralsight video by Steve Smith called "Solid Principles of Object-Oriented Design." That was another good resource for information on that.
Yeah, excellent resource. And he, as I mentioned, he even pointed out his follies in the past and how he got around those. So when he learned about dependency inversion, how he went and took that. So you'll get a lot of tips of things to look at along the way when you're doing this kind of stuff.
Yeah, we also mentioned Michael Feathers and Uncle Bob, and they write on the Object Mentor blog, and there's a wealth of information for just kind of principles and best practices around object-oriented programming, and you can download some PDFs of papers they've written there.
Yep. So now we're going to get into our tips of the week. And so mine is in the new Visual Studio 2013. You now get the ability to modify code while you're debugging, even in 64-bit mode.
Woo!
That's something we've been missing forever.
That's going to be dangerous.
That's beautiful. No more recompiling, reloading, especially if you're dealing with ASP.NET. Oh my God, waiting for IIS to spin back up and all that. So, yeah, that's glorious.
Yep. And
that'd be a fantastic site.
And also, my tip is basically one I just found out about, which is Control-Shift-S, which saves all of your modified files.
So you didn't know to save your documents?
I'm a religious saver.
So much.
I save. I even commit ridiculously. I cannot go 5 seconds. If I type
we've talked about your ridiculous commits.
Yeah.
Trust me.
I like to save. But what this is really helpful for me for is saving solutions in project files. So sometimes if you delete or rename a project or something like that, the actual SLN file won't get written to. And this is a problem if you go and you kind of do your, if you're using source control and you do like a status or an update or commit or whatever, a lot of times you're going to miss that SLN file or CSproj files because they weren't written to disk. And so you do your commit, and the next day when you close your Visual Studio and you see that message saying like, save changes to the SLN file, and you're like, oh crap, that pull request I put in yesterday is missing some stuff. So Control-Shift-S whenever you make changes to projects or properties on your solution is a big help.
So my tip for the week, I found this really cool little project that I thought was a nice dovetail from our last show, which was about Link. And this is a project called Link to Twitter. And you can find it on Codeplex at linktotwitter.codeplex.com, and also on Twitter at, go figure, twitter.com/link to Twitter, but the Twitter in that one doesn't have any vowels. So it's a nice cool little project where if you had a need to go through various tweets and you wanted to do them in a link fashion, here's a link provider for Twitter now. So we were talking about some of the crazy link providers that were out there. I think
Link to Flickr.
Flickr, there you go.
Flickr,
That's the
yes.
one I was looking for. It came up. And now we got Link to Twitter. And I thought that was just a really cool little project. And it's very current. There were some updates just this month to it. And you could say something like from tweet in context.status, where tweet type equals status type public, select new tweet, and get some neat little information from it. So it was pretty neat. And they have examples in there where you can integrate this into LinkPad, which was also another thing that we had discussed last week in our show notes, or in our show. So I thought this was a great little tie into that.
Excellent. And speaking of Twitter, tweet us. Tell us what you're working on. Tell us what you like. Tell us what you hate, and all that kind of stuff at Coding Blocks.
And we're very funny too, very entertaining.
Yes,
and on topic.
Always.
Yeah, if you follow a lot of people on Twitter, you get a lot of noise. But we try to stick to the important stuff like coding and Icepocalypse.
Yeah, I definitely had some Snowpocalypse in there.
Yeah. That was a big deal.
Yeah. That's why we're so late on getting this episode out, as a matter of fact.
Well,
there was an inch of snow, guys, on the ground.
I mean, you say it was a big deal, but I mean, really, elsewhere in the country, it wasn't so much a big deal. But here in the South, we kind of went overboard. Which there was for any Top Gear fans out there, they had a great thing on recently where they had somebody had posted a sign, the signs that go over the freeway, the digital signs where they can replace the message and whatnot. And it said something along the lines of, "Oh my God, snow! We're all going to die."
Hey, look, it was a big deal. We all had long commutes home.
Again, it was a big deal in the South.
Yeah. So, we do stay on topic, but definitely hit us up at Coding Blocks. We'd love to hear from you guys and interact with you. And with that, I think that's a wrap. We'll be putting the links and the show notes up on the site, and you'll be able to find that at www.codingblocks.net/episode 7.
And also make sure to subscribe to us on iTunes. And I've been really getting into the Stitcher app lately, which has been really cool. So make sure you subscribe there. And we also could desperately use your reviews on both Stitcher and iTunes. Lets us know how we're doing, and also kind of exposes us a little bit more, which is good for us. So also,
regardless of which app you prefer, or what podcast source you prefer, we would appreciate some reviews and
it's highly feedback. Motivating is what it is.
Yep. And also, contact us if you have any questions or topics. Leave your name so we can get a hold of you, and preferred method of contact, and also shout out. If you're okay with being mentioned on the podcast, who wouldn't? And especially if you give us a review, hint, hint.
Yeah. You could even leave a website. We'll pimp it on the show.
Yep.
So that's a wrap.
What if it was a pimp who wrote in and wanted to pimp his pimping website?
I pimp it.
I'm fine with that. Yeah, I got no issues.
Some legal questions might come in there. But I tell you what, you can provide your answers. You can visit us at codingblocks.net, where you can find our show notes and examples, discussion, and more. Send your feedback, question, and rants to comments at codingblocks.net. And be sure to follow us on Twitter at codingblocks.